So far, so good. Let me say a word or two about Pradip, and then I'm going to ask my colleague Ling Wong from the Gates Foundation to flesh it out. The only thing that I think you should know about Pradip is he's obviously a very successful scientist and proposal writer, which is why we've brought him forward to go through his proposal with you. Secondly, he's a movie star. If any of you have seen the Grand Challenge Explorations video, I don't want to say that every scientist in that video are there any other scientists who were in that video just before? So obviously we've got 3 fantastic movie stars here, and we welcome them all, and that's just terrific to have such great movie stars here at the proposal development workshop. And then finally, there is something I want to say, which is I don't know how many of you have actually put up a proposal that you've done in a fishbowl to a group of 80 colleagues and gone through it. But it takes a real element of maturity and sharing and commitment to do that, because as we heard earlier, everything has holes. And I just want to personally very much thank Pradip for agreeing to do that. And I know it's out of your commitment to strengthening not only your own science and learning from colleagues, but also sharing and helping. And so that's very much appreciated. And being in a fishbowl is a great thing for somebody to do, because it's very helpful to colleagues. So Pradip, I just wanted to thank you for doing that. And then in terms of your more formal roles, other than movie star, fishbowl, and success, Ling can say a few content-based factual words. Thank you.
Thank you. So briefly, I wanted to introduce Pradip. He's one of our first Phase 2 GCE winners. And so he was in that first group of applicants and applications that we received for Phase 2. And at a point where we were still developing the program itself. And so much of what Pradip will share about his program, about his proposal, is the process that he went through to get to where he did with the final product. And looking at the final product, it stood out from the rest, and that's a key piece. So I'll, without further ado, turn it over to Pradip.
Great, thank you, Pradip.
Okay. Well, while everybody's feeling so good, I should put in another application, huh? I think I'll turn this off, and hopefully this one's working. Very good. I was invited here. I'm very pleased to be here. I did come in the spirit of exactly what was described, try to share my thoughts on how we prepared this application. I'm very grateful to the panel for bringing up all the important points in a very general way about what grantsmanship is about. And what I thought I would do is take our proposal and apply all of these principles and show you how, in a very practical way, on a ground level, what are the choices we made as we went along. And we'll see how it goes. I've never done this before. So this morning, what I would like to do is actually show you in very general terms what you will be reading. Because I think giving you a proposal and leaving you on your own and trying to read it in less than an hour and coming up with insights might be a little harder than if we first go ahead and show you what the proposal is about, maybe discuss the science briefly, and create a framework so that you now focus on the grantsmanship part rather than trying to juggle both the science and the grantsmanship. And I've tried to highlight what I think are the kinds of things folks are looking for in Grand Challenge programs. Is there a key neglected problem that needs some attention? Is there originality in the proposal? Is it a competitive application? Is it well put together? Is it a good fit with this particular sponsor's plan? Because there are lots of different opportunities these days to put projects in different environments. And I'd like to highlight that this was a good fit for us. And I want to touch on something because I'm very sensitive about the fact that there are lots of different folks applying from very different backgrounds, different ages, different countries, different levels of expertise. Are there any kind of unfair advantages to people who are more established, to people who are in Seattle. And I'd like to promise you that I don't think so. And I'll try to point out that, if anything, there are probably higher burdens for certain things. And that was in my mind as I was writing the proposal. Why go to the Grand Challenge program for this particular proposal? So I'll touch on all of these. Briefly, we work on malaria. I've been working on malaria for, I think, 25, 30 years. I don't count anymore. I celebrated my 50th birthday several years ago, so we stopped counting now. We work on malaria. We started with very simple ideas about drug development, that what you wanted was some important enzyme that was essential. We were going to hit them with molecules that were tight binding inhibitors, and we would cure malaria in a few years, and we would move on to working on cancer and other important problems. Well, that framework for how you develop drugs has really not helped us very much. It doesn't have much predictive value. And most of my career has been on trying to figure out where the gaps are in our framework for how to develop drugs. And probably one of the most important things that's come out of this type of analysis is that the ease with which resistance occurs is really important. That probably makes and breaks anti-malarial drugs, especially as single agents. And we are seeing over the years that even drugs that lasted for decades eventually succumb to resistance. And when that happens, there are multiple mutations in multiple loci, often 7, 8, 10 mutations in more than one place in the genome that gives rise to something like chloroquine resistance. We don't have artemisinin resistance yet in a classical sense. When that happens, it'll be another one of those frightening things to look at in the genome sequence on what the parasite had to do in order to become resistant to artemisinin. In anticipation of these kinds of problems, we thought just telling bad news is not enough. We are optimists at heart. We face bad news because we're trying to move forward. But once you've identified bad news, you want to create a solution. And this proposal was about an attempt to a solution to extraordinary abilities of malaria parasites to mutate and to develop resistance. And the idea was, if we knew the mechanisms that the parasite uses to develop mutations at extraordinary rates, we ought to be able to find molecules that can block those processes, and those molecules could be used as adjuvants in addition to traditional drugs to improve the lifespan of our traditional ways of treating malaria. The concepts, even though they revolve around drugs, have implications for things like vaccines. We don't have successful vaccines against malaria, but when they are implemented, some of these same issues will come up. And people who are thinking of vaccines ought to be thinking about what the parasite is capable of doing in order to avoid countermeasures. It also has implications for other parasitic diseases, other infectious diseases. So we had to somehow convey this idea of optimism against great pessimism, convey the idea of the fact that even though we're dealing with malaria, the implications are for things above and beyond drug development for malaria. In terms of originality, I think we were dealing with originality both in terms of the question. Most questions in malaria drug development revolve around targets, compounds, and maybe to some extent resistance against specific compounds. Here we're dealing with a global ability of the parasite to change. So it's a new type of a question. Artemisinin resistance may occur. When it does, it'll happen after several decades of use of artemisinin. The processes that lead to artemisinin resistance can never be replicated in a laboratory situation. How do we study these kinds of processes? And so we had to rig up a system. We had to put together an artificial chemical system that would allow us to develop resistance easily under laboratory conditions. And so the approach itself that we developed was new and interesting. Hasn't been done for malaria, possibly for other systems either. So those are some general things that I wanted to bring up that you should be looking for in the proposal. Did I convey that correctly? Did I emphasize the right things in the introduction and so on? In terms of the application itself, these are the things that you've heard before. It has to have clear goals. It has to have logical plan and priorities. You have to have some idea of what the possible outcomes were. Somebody raised the importance of looking at things that you wanted to see as well as things that may crop up that does not agree with your hypothesis. Facing that up front and saying these are the things that we will be looking for that might tell us that our system is not working correctly, are all things that are discussed in the proposal. And of course, future directions. Now, I say here that this was a starting framework for phase one. Even though most of you are preparing phase twos, I wanted to just bring this up because this sets the platform for what happens in phase two. We were already thinking ahead in terms of what we would want to do if we had more resources. So somebody in the audience said, you know, what are the key measures of whether you have succeeded in demonstrating feasibility? And so that was all built into phase one. They're pretty simple, humble goals. But if those goals could not be met within a period of a year or so, then maybe we were being too ambitious about what we had wanted to do for phase two. So we had to demonstrate that those things could be done. And there were some questions on whether that would happen or not. So when we wrote the phase two proposal, again, the people who wrote the instructions ask you to write in your own words what you had wanted to do in phase one, what did you accomplish, what are some of the things that turned out exactly the way you had expected, and what were some surprises. Of the things that were surprises, does it make you change your direction a little bit? And we had elements of all of these things when we got to the point where we had to write a phase two. So the first question I've listed up there is, was feasibility established? Were we able to do some of the things we wanted to do? I'll get to the science briefly, and I'll tell you what the issues were. But in terms of general discussion, we showed that the two critical things that we wanted to be able to establish for us to invest our energies and resources into phase two had been established. Were there surprises? And you'll see, yes, there were surprises. The genetic method that we had proposed to zero in on an important mechanism for how mutations occur, the process worked, but the underlying biology that's driving these hypermutations turns out to be quite complex. It involves 3 different regions of the genome. It involves segments that we could identify within 80 kilobases or so. Trying to zero in on the exact gene that's involved in the process was going to turn out to be more important, and there were probably more than one solutions. And so the biological approach started to slide as a lower priority, even though it was a higher priority in phase one. In phase two, it shifted down to a lower priority, and we started gaining more confidence that the chemical approach, where we were going to do a screen to block the process of hypermutagenesis without necessarily understanding all the different components that go into the process, was going to pay off faster. So there is a surprise. There is a strange, a kind of a realignment of strategies to try to bring up the chemical approach, the screening approach, as a higher priority for phase two. And you'll see some of that. This business of creating confidence in your reviewers is really important. Many of the points that were raised by the panelists are things I think we covered fairly well. You want to establish your own credibility. You want to show awareness of what others in the field are doing. So we try to reference their work. With our own project, we tighten up the goals based on what we learned in phase one. We give more detailed plans and priorities, and we continue to emphasize the implications of our work. Part of the reason for raising the chemical component as a higher priority was that understanding things is a nice thing to do, but if you ever listen to Bill and Melinda Gates talk, it's about urgency. Millions of people are dying out there. Drugs against malaria are not coming up fast enough. We're in a perilous situation where only a few good compounds are out there. If we can find ways to protect compounds that are good, that's more important than waiting for the biology to catch up and then deliver drugs. So we kept emphasizing that in our proposal. When it came to budgets, every part of the proposal has to have creativity, including how you put your budget together. The budget is an opportunity, again, for you to convey what you think is important. It is the Gates Foundation proposal guidelines have a very specific way in which they list objectives and in which they list different key things that you're going to do. We actually rewrote the proposal itself to match the way that the budget spreadsheet was set up, so that anybody who's reviewing the grant could quickly go back and forth between what we were proposing to do, how we were going to do it, how much resources we were asking for, and see what the different things we're paying for if they go back and look at the science. So the very tight connection between what we were trying to do science-wise and what we were asking for in terms of resources. There is a little bit of planning for uncertainties, because if we knew everything that we were going to do and how things were going to turn out, that would be a boring proposal. This is about grand challenges. There are unexpected things that were thought to occur. One other thing that came up in the discussion that's not on my list here, but I think is important to point out, is we have weaknesses. Our lab is very good at a lot of different things, but one of the things we had not done enough of is a lot of chemical screens, and we don't own large libraries of our own. So we conceived that as a weakness of our own before we wrote the proposal, and we partnered with Kip Guy at St. Jude's Hospital, who we think is one of the bright scientists who has incredible resources, is a generous human being to interact with. And so we made sure that we brought in a partner to help us with that particular component. Partly it's about building credibility and confidence, partly it's about using the resources we have in our community. I would only alert you that even this relationship where we know each other well slowed down more than I would have expected, just because intellectual property people get involved and so on. So if you're going to have partnerships, it's good to get that off the ground early. Don't wait till the end of the proposal to call someone up and say, I want you to partner with me. It all worked out very well. Peter, how am I doing and how many minutes do I have?
Good. You've got 10 minutes, and in that 10 minutes, you do your thing, and we just frame where we're heading next. So
Okay.
you'll let 8 minutes to?
Oh, yeah. Yeah. So what I thought I would do next is actually give you a little bit more detail on the science, so that as you're reading the proposal, you don't spend too much time trying to understand the science, focus on the way the ideas are conveyed and presented. So my lab works on many different things. I'm in a chemistry department. We develop drugs against malaria. We have specific targets we go after. We do a lot of synthesis. That's not an appropriate type of work for a Grand Challenge program. There was a judgment that we made. There are other ways of getting that kind of funding, and so that kind of work in our lab is funded by Medicines for Malaria Venture. We have a lot of work on trying to decide how targets are pursued and what is important about specific targets in malaria parasite. That's a very basic science question. What makes for a good target? That for years has been supported by NIH in the form of R01 grants. We have very futuristic projects on using microfluidics to understand the nature of pathogenesis. What makes people sick? What makes them die? It's something that's really not well understood in malaria. And one of my postdocs and I actually did put together a Grand Challenge Explorations grant proposal for that, and it didn't fare very well. So, matching what the funders want to do and what you want to do is really important, and sometimes things don't work out. You go back to the drawing board and rethink what people want to do. I don't want you to think I'm a magician and I can raise money all the time. I wanted to put that example in there. We have a big project on mutagenesis and resistance through the Grand Challenge Explorations now, but we're also looking forward to asking questions of how relevant this is in the field, what's going on currently in the field, and so on. So that's a different type of a project that requires larger scale money. So I wanted to show you that matching between the different projects is important. I don't have a huge amount of time to go through this, but creating a framework for how people think about resistance and how parasites are incredibly good at resistance need not be sort of a qualitative, hand-waving argument. If you put together some numbers and prove to people that what the parasites are doing is incredible, getting 2 mutations simultaneously is unlikely to happen in decades. Getting 3 mutations simultaneously by conventional ways of thinking about mutagenesis should never occur in our lifetime. So when parasites generate 7, 8 mutations per locus in the context of developing drug resistance, to me seemed really extraordinary. And we argued those points back in 1997. Malaria didn't have the kind of attention it does today. Now we can revisit these questions with new resources, with new people who are willing to campaign with us, for us, and we can now argue for some of these ideas. Be solid, be grounded, be quantitative whenever you can. Okay? Tools, we have tools with which we can develop resistance at very high frequency. One of the arguments in the proposal is that this is amazing. We can reproduce the ability of the parasite to develop resistance rapidly within one well of a 96-well plate. When we were able to show that we could do this with 100,000 parasites, it now created an opportunity to go do screens directly to look for molecules that would block this process. We didn't need to understand the biology. This was a major breakthrough, and that needed to be conveyed into the phase 2. I'll skip this part. This is the biology part where we looked at progeny from a genetic cross, hoping that we would learn exactly what the genetic locus is that is providing the certain parasites to develop resistance at extraordinary rates. We would have been very lucky if the genetic cross pointed to one specific part of the genome that was contributing to hypermutations, if that particular segment had just a handful of genes and we could knock them out individually and we would learn something about what gene was promoting all these processes. What we actually found out, as you will see in the proposal from phase 1 studies, is that there are 3 major loci that are contributing to this. The limitations in terms of where the crossovers took place got us to within about 80 kb, 40 kb of where the genes are, and we can still figure out how to go about finding the exact genes that contribute to the process, but it didn't seem like it would be the higher priority for phase 2. The other screening process was the higher priority. So let's see if all that comes through as you read the proposal. There are a lot of people in my lab who do very nice work, who are very important in helping us get to where we are at today. Many of you have met before, and some of you know some of the folks that are listed here. I wanted to make sure that all your friends got acknowledged. Funding from agencies that have trusted us to take on some of these more ambitious, crazier ideas is really important. This wasn't the way the world was when I started working in the malaria field. So it's really exciting. I feel like I'm reborn as a scientist again. So I'll stop here and let's see how we do.